All right, hello and welcome. So, just a quick heads up, I'm probably going to start doing these streams around this time for the foreseeable future. Last time I did this time, I got much better viewership, much better engagement, and so it seems like more people are interested in this time period as opposed to earlier in the morning. So, with that in mind, let's just go ahead and get into, or I guess I'll just start talking a bit about what I did, what I'm going to be doing here. So, did like a really quick bit about parsing and some of the structures that I'm going to need in order to do that. This is definitely not all of them, by the way. There's going to be plenty more. But yeah, so let's just get into it. Let's see. Do I need to have? I probably should. Just adding a couple other expression types. Because primary expressions, if you don't know, that's things like actual literal values. So, integers, strings, etc. And I also, this isn't going to change anything with the lexer, but once I start working on parsing and evaluating, this little change to the syntax will be pertinent. And that is, I discovered something kind of neat. So, basically, I was working with this tool, or it's a program called AGS. I guess actually it's a framework. It's a tool you can use to create GTK windows and widgets and whatnot for like making a bar. Like if you've heard of Waybar, which is a bar program, a status bar for Wayland. It can do things like that. It can also do some other cooler things. And so I've kind of been playing around with it. And one of the neat things that I discovered using that is that I think this is JSX can do this. You can actually do something like, return and then something, I don't know. So you can do something a bit like this, and it'll actually, like if this Boolean here is true, then it will display this, otherwise it won't. And I thought that was like super cool, because normally the way that you'll see that sort of stuff done is using some kind of ternary expression, so something like and then I guess, I don't know, something like this, which I dislike. I don't like this weird kind of broken up expression operation thing. And so this is why I was saying, having if statements be expressions instead would kind of fix that, because I could do something more akin to this. If Boolean, yeah. Something a bit like that if I do it the other way, the kind of more similar to Rust or other functional languages. But I just thought this sort of syntax was kind of neat, and it's primarily for when you either want to have all or nothing, like your else condition would just be non-existent in this case. So that was cool. That's kind of neat. And I'm actually kind of trying to think of a way to make it so that the result could actually work with if-else statements, and I think the only way it would work is if you used some kind of XOR kind of thing here, and I don't know, it worked out to just being a little weird, and so I'm going to stick with my plan to use if statements as expressions, but I just thought that was kind of a neat thing, and so I would talk about it. We'll get rid of that, and I am going to, let's see, do I want to just get started? Real quick here at the top, we're going to throw in this. And program is going to, let's see, actually I should put this, hold on. Go to that. Let's go here, and then we'll just go ahead and shorten it. There. Okay. So, I'm going to go ahead. I'm going to ignore doing all of this. There's a lot here that I would need to write out, and honestly, I prefer to kind of just work my way up. So that's what I'm going to do here. Okay. So got a couple different expression types here. I'm going to go ahead and define a few of these. So binary expression, and actually we'll just call it bin. There. And I don't need to do primary expression. That is going to be that's not going to be its own separate structure, because primary expressions are going to be stored wherever the expression is located. Actually, I can't do that. I have to actually make a structure to store that, because otherwise it's just not going to work, because the primary expression is going to be storing essentially just a hold on. It's just going to be storing the value, but in order to do that, I have to actually have something that can also just be evaluated as an expression type. So, and here I am going to, let's see, I think now's the time that I need to actually create a union. Okay, and then that is going to have a bunch of different things. So let's go up to the top real quick. Do some includes here, because I need standard int. I don't think there's any others that I need for the moment, so I'm not going to bother with that. But, okay, so want uint 64 underscore t, and it's going to be u64, i64, f64. What else? We want a character array. Let's call this, let's do chars. So that's easier. And then, yeah, let's do string. And finally, just in case, it's unlikely this is going to be necessary, but just because it may be necessary, we'll just go ahead and put in, I guess, just pointer, just to make sure. And I'll shorten this too, because it's relatively easy. Okay, is there anything else I'm missing? I don't think there is. Pretty sure that that's everything. Yeah, I think that's it. Okay, I'm pretty sure that's it. I'm probably mistaken, but I think that's everything. And for those of you who are not aware, a union is basically just a way of organizing data where you can pick one of the options. So first off, you generally don't want to have two things that have the same data type unless there's some good reason to. But it allows you to interpret data in different ways depending on what you want to do with it. So you could actually, technically speaking, you could probably get away with just casting data and not using a union. But a union is, as far as I'm aware, it's more readable, I would say, typically. So I might be wrong on that, but I've seen unions used. Casting data types is something you see in don't know how best to describe that. I just don't want to do it that way. I'd rather avoid it if I can. Okay, so let's take a look at unary expressions, and this is going to have an expression, and this is going to be, I think it's operand, and then, let's see, do I want to just do, I think we'll just do int type, or maybe, yeah, we'll just do operator. There we go. And this is going to just end up being the token type for the operator. So that's relatively simple. And then for binary, because you need two of them, I'm going to do left operand and right operand. Oh, and then of course operator. There. All right, and there's going to be a lot more than this. These are just a couple really, really basic ones. So, okay. Oh, and before I leave, let's just go ahead. Let's see, I guess in parse, maybe. I think here, is there anything else? Oh, we want to give it the lexer. Because it's the one that's actually going to be going through and using the lexer itself. And what else? Can't think of anything else that I really want to put in here, so we'll just go ahead, take this, go to the source file here. Okay. All right, so start defining some functions in here. So parse primary expression. That's going to take. I don't think it needs program. I think it's just going to take the lexer. Actually, hold on. We'll have it take a primary expression, so yeah. And I'm just going to change this to primary as opposed to prime. I'm quite certain that using prime there might not be the best idea. Okay. We'll do that, and then the lexer. Then we want, let's do, yeah, we'll put this lower. Okay, so parse unary expression. actually I need to break this up into smaller chunks. So like, for example, parse binary expression is a bit too generic. So we'll start with something like add expression. But it's going to take a binary expression structure. This is more so just to deal with order of operations, because obviously if you know anything about order of operations, you multiply things before you add things, before you apply negatives directly to numbers, which would be a unary kind of expression. So let's go ahead and throw in a couple things in here that we will need. So that, copy, paste. So additive and multiplicative expressions, let's copy those. And I should probably go ahead and put return values on these, because lexing, it's a little more difficult to break something when you're lexing because you're not doing any kind of interpretation. But parsing, there's a lot of things that could go wrong. You could be missing, maybe you use a plus sign and then don't put anything on the other side of it. Well, that's an error. So let's go ahead and put ints on all of these. Okay, let's get started here. So we've already got the primary expression. And I think I want to have that allocated outside of this. So we'll just assume that it's allocated for the time being. And let's just get started. So we'll do token equals lex lexer and actually, do we want to do this? Okay, we'll do a switch case. Let's see, token type equals, actually, don't want to do that. There. Okay, token type. Let's start with identifier. It's the first one that's going to be listed. Primary expressions are like identifiers are a valid primary expression. What else? I think I might be missing something in the primary expression structure. I'll deal with that in a minute. What else? I want to do integers. String. Alright, we'll do float. String. And the last one. I think that's all of them. We want true and false also, because those are valid primary expressions. We'll do true, false. Also want to include null. people that did it wrong, and let's start with integers, because that's pretty easy. Hello again. And, okay, so let's see. So we'll go expression, and then for this is going to be unsigned. I think that's all that it needs at the moment. Okay, so we'll stick that. It's going to be F64. Oh, shoot. Don't know why I was doing that. So I'm going to have to actually convert these now. Okay. I think I need a helper function to do this. So, one sec here. Okay. All right. So let's see. This is going to return a double. What is it? String to F64. One sec here. All right. So, yeah, do string to F64, and that is just going to take in a string and a length. And I just realized I need to. I'm going to go ahead and just go to the header file right now because I need to include a lexer. Otherwise, this isn't going to work. And down here, ooh, this is going to be no fun. Okay, well, I'm not totally sure how I want to go about this, but I think because I need to know the data type, so something like that, but not quite sure how I want to deal with all of it, because this isn't going to work very well given that I'm using a union. So I think it's going to have to suck it up and do what I was saying before, where I just have one 8-byte chunk of data that just gets converted to the various options through like casting or something like that. wasn't wanting to do that, but might be the only way to go about it. This works reasonably well with what I'm doing here. Anyway. Let's get that, and then let's do static u int 64 to u64. Yeah. Okay, what else? I should also include something that goes from, because I've also got the ability to make hexadecimal characters and binary and all that kind of stuff, or not characters, digits, hexadecimal digits, binary digits, octal. So I'm going to have to also include stuff for those. Do I want to do that just in this one? I guess I could. It's not stopping me, and it would certainly make things easier, at least in some degrees. Okay, so we want that, and we'll set that equal to 0, and so everything's going to get fun. Let's see, if string at, what is that? That would be 1, I think. Okay. Let's start with just regular decimal integers. So for this one, it's, let's see, result equals result times 10 plus, actually, no, we need to put this in a loop. It's for 9. I plus plus, okay. There. Let's see, string at I, what is it, minus 0. Let's see, yeah, that should work. So that's just going to build out that integer progressively. At the end, just return. For this, very similar. Major difference difference is actually... No, there's no easy way to get that to work. Unfortunately, hexadecimal kind of throws things off a bit. Everything else works great. I could just combine for some context, because I think I might just be speaking without explaining anything of what I'm saying, and then I just kind of move on. I was thinking of moving this chunk of code outside of the loop and just having this be a variable that I would set as like, a base or something like that within here. The problem with that is I still have to figure out how to do stuff for hexadecimal, and so that's kind of throwing a wrench into things, because you can't just use this neat little trick that I'm using here for hexadecimal. So anyway, kind of annoying, but could be worse. Okay, times 8 plus... Okay. Then. Huh. Hold up. I can make this work. Okay, hold on. I got it. I think. Let's see. Anything. Okay, base equals 16. I'll just go down the line here. Get rid of that. Yeah, there we go. And so the way to solve this is if string I is greater than or equal to a I guess, actually, technically speaking, I can just do something like is alpha. Well, actually, that doesn't really speed things up. Hold on. So one thing I also just realized, we do string plus equals 2. Just because I want to make sure to skip over those. Actually, is that? Hold on. I think I can still make that do what I want, even if it's a constant. I might be wrong there, we'll see. But I'm adding 2 to the string just to make sure that it skips over the 0x that you'll see in those. So like, you're writing hex, you usually use something like, something like that. So you just want to make sure to skip over these 2. Okay. All right, so let's see. If not is digit. I think that'll work. Then just go here. Like this, and then it's going to be, oh, actually, that's not going to work either. Hold on. Let me break this up. My preferred method here is not going to work. Okay. I'm going to say plus 10. I think that'll work. Else, just go like that. Okay, I think that's everything that I need. And I also realized this is totally unnecessary, because there is not going to be a case where, and actually, I'm just going to change this to that and that. I'll just go back up and fix the functions. There we go. Okay. All right, so what I'm going to do here, go while lexer token type does not equal end of file. I'm just going to have it lex things. And then, let's see. Gonna have it parse, there we go, parse primary expression. Okay. I need to find another enum to store. Yeah, there we go. Or maybe we'll call it literal type. Maybe. I guess I can just have it be in the expression type as. Yeah, we'll do it that way. Okay. Identifier. Oop. Not sting. Okay. There. And both of these are going to end up being type Boolean. And it is just going to see for true, this is going to be equal to 1. Yeah, cannot type. Hold up, actually, because I think I forgot. Oh, that's right. I basically just made that the only thing. Okay, I can fix that. It's parser.c. Okay. So what I'm going to do here is go like that. I'm just going to change all of these and alrighty. guess we'll just do something like this. And then something like that. Go. I think this is actually just called string, so probably shouldn't do that. Okay. Actually, I don't even need to do that. Hold on. Let's go like this. Okay. Go ahead and include the string header. We're going to try to compile this. It's not going to work. I'm like 90% sure, but let's just try it anyway. Yeah. Of course not. Okay. Primary expression. I switched that. R type. Okay. 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 I need to make it anyway. Those should all be commas. And actually, var type might be a better thing to use there. So I'm going to go ahead, I'm going to populate this real quick. Oh, whoa. Why is that lowercase? else is there? Should probably also include strings, so there's that. Integer, oh, right, floats. Make sure to include null. Okay, I think that's everything. So we'll get rid of these, I think. Or not. No, probably shouldn't. So variable types, that's a different thing. And actually, I'm going to leave that as is. Anyway, that was a completely, or not completely, but a currently pointless tangent. Okay, those are all good. Oh, because I didn't change this one, so that should be primary. Nope, hold on, gotta go here too. Int 64. Okay. I think that's everything. Of course I screwed that one up. Okay. Hold on. Yep, completely forgot about these. Okay, break. And at the very end here, we'll just have to return 0. And this doesn't return anything. Do double result equals 0.0. And then just return result. There, problem solved. Okay. Conflicting types, double, yep. With type int. Wait, what? Yeah, okay. Okay. Now, forgot. Hold on. Not make. Not make. Hold on. Okay. What time is it? Definitely not going to have enough time to actually go through and test this, but let's go to parser.c, parse, and I guess that's possible. Hold on. I think I can do this. Okay. So we'll just get rid of this and go parse. We'll define a program here. Lexer, and that should be pointer. There we go. Oh, not happy. What's going on? Type in program. Oh. Because I forgot to include the parser. There we go. Valid expression type. Hold on. Hold up. Okay. Why is it literally every single one? It's not every single one, that's why. Okay. Okay. Just going to go ahead and define. Let's put this at the very bottom. Oh, don't want to do that. There we go. Okay. Now, it looks as though that is the end of the hour. So, thank you all very much for watching, and I hope you enjoyed. And I should also be on tomorrow, and this time I am going to be on hopefully at the same time. So, catch you then.